Welcome to Class TV. Adding myself, Aliwi Tosin. Now, this is part 5 of equilibrium of forces. Here we'll be taking what we call equilibrium stability. Equilibrium stability. Now, there are 3 types of equilibrium stability. One, we have what we call the stable equilibrium. Stable what? Equilibrium. We have what we call the unstable equilibrium, and we have what we call the neutral equilibrium. Now, what is a stable equilibrium? We say a body is said to be at a stable equilibrium if when the body is slightly displaced, when we slightly push the body tends to return to its original position. Now, this is a funnel shown to us. If we have the base of a funnel resting on a plane surface like this, now when we slightly displace it, that means when we just push it small, what happens? The tunnel tends to move a little bit and still balance back to the same original position it is. The funnel tends to just move, bend small, and come back to its original position. And so we say that the funnel, the base of a funnel, or a funnel resting at the surface of a plane shape with its base, is an example of a stable equilibrium. Another example of a stable equilibrium is when we have an egg placed inside a bowl. Yes, an egg placed inside a bowl. This is an egg. Let's assume this is a bowl, and you place an egg on it. What happens? You see that the egg will comfortably sit on the bowl. It will comfortably sit in the bowl, which means that the egg is a stable equilibrium. Do you see that? The egg is a stable equilibrium. Now, let's now take another example of a stable equilibrium. Let me just mention this. Is also when you are sitting on a chair. Okay, when a chair is resting like this, when you push it a little bit, what happens? It still comes back to its original position. So we say that it is at stable equilibrium. Now, I am citing this as an example of an unstable equilibrium. What is an unstable equilibrium? An unstable equilibrium, we say a body is said to be at unstable equilibrium if when slightly disturbed or displaced causes the body to tip over. The body does what? Tip over. Now look at this funnel now. When your funnel is resting on its apex, on its tip edge, like this, what happens? Any slight touch, even when there is when air exerts force on it, what happens? It immediately falls off. Falls off. It cannot return back to its original position again. So we say it is an example of of an unstable equilibrium. When you push this, when you push this funnel the way it is, it cannot return back to its original position again. We say it is an example of an unstable equilibrium. Now, for a neutral equilibrium, what do we say? An equilibrium is said to... Okay, let me give one more example on this unstable equilibrium. Another example of unstable equilibrium is when you have a bowl turned upside down, inverted bowl, right? You now place an egg on it. What happens? Any slight touch, any slight displacement, the egg does falls off. It cannot come back to its original position again. We also refer to this as an example of an unstable equilibrium. Now, let's now go to neutral equilibrium. What does it mean for an object to be at a neutral equilibrium? We say a body is said to be at neutral equilibrium when it is slightly displaced. The body remains in its new what position. When you slightly displace it, it moves completely to a new what position. Like this now. You see a funnel lying flat on the table. What happens? When it is slightly displaced, it rolls off to a new position. We said such an object is at what? Is a neutral equilibrium. Okay? Another example that we can use for that is this. If we have an egg placed on a plane surface, now what happens? This is the egg. Now immediately you displace the egg slightly, the egg moves completely it rolls off to a new what position. So we say that what the egg is in what a neutral equilibrium. Okay, so that explains the concept of neutral equilibrium, unstable equilibrium, and stable equilibrium. Now I want us to note this, that when the center of gravity of a body is high, when the center of gravity of a body increases, the potential energy of the body does what? Increases, right? Which brings about what? The instability of the body. What am I saying? When this body here is displaced, W, that's what? Weight. When it displaced, what happens? The what you call this? The center of gravity moves higher, increases. And when it increases, it still has the capability of what? Of coming back to its original position back, because its potential energy also what? Increases. But when we have it this way, right, the center of gravity is already high, and I said this in my previous classes, that when the center of gravity is high, then a body has a tendency of falling off. And that's why I started the example of a top player falls easily than a short player that does what? Still find it easy to gather himself when slightly pushed in the football field. Now, this is high. Now, looking at it, see the center of gravity is farther away from the what? From the ground. For any slight displacement, what happens? The center of gravity drops. See that? Assume this drops. So which means when it is slightly displaced now, the center of gravity drops to something like this. Right? Like this. So which means that what? The decrease in center of gravity brings about decrease in what? In potential energy. And decrease in potential energy leads to what? Unstable equilibrium. I mean, leads to, yes, it happens when it is an unstable equilibrium, and it makes it what? Falls off without returning to its original position. Okay, on this note, we come to the end of this great topic about equilibrium stability. In our next class, we go to how to determine the mass of a body using a meter rule. I read myself Alewi Tosin. Thank you.